So last time we were talking about hydraulics, we left off at actuators, and we talked about our different types of actuators. We've got single acting and double acting. What's the difference? What is, if I ask you, tell me the basic difference between single acting and double acting, what is that referring to? What's that? Of what kind of an actuator? Double acting. Okay. It doesn't mean it can't move both directions, right? Here's a single acting actuator. It's going to move to the left up here in the top, right? It's going to move to the left when there isn't pressure over here on the fluid side. Fluid's going to push it to the right. So fluid provides it's single acting fluid essentially. And in that case, then a spring is going to push it back. And so then we've got our two double acting actuators here. We've got our double acting unbalanced on the left here and double acting balanced on the right. And what's the difference between those? What is it referring to when we say balanced versus unbalanced? So the area that the pressure acts on, which is ultimately going to result in a force difference, right? So in this unbalanced actuator, bottom left, you can see the red on the left there, red-orange, I guess, is going to it's going to act on a lot bigger area than the fluid on the right, because the right, there's no force on the area where the shaft is coming out. In terms of, now, I mean, I guess I should say there is force on the shaft, but it's not pushing it in a direction that's going to move it. Okay. An alarm set, I forgot about that. So the fluid that comes in on the right here is only going to act on this small area above and below that shaft, or around, and kind of a donut around the shaft. And so it's going to have a lot less force moving to the left than it is to the right. And so a balanced actuator, you can see, has the two shafts. The area that the fluid presses against is the same. Some of them will have the ability to connect something at both ends. Okay. You don't always connect both ends. Sometimes you only connect one end. Some of them will have one where there isn't a connection on the opposite end. In that case, what's that called? Remember the name for that? Dead bar? Okay. That's a good guess. Not quite. It's a dummy shaft. Okay, so the dummy shaft doesn't actually control anything. Okay. So those were examples of linear actuators. Okay, they're going to make linear motion. They're going to move in a line, right? And those can be broken down into two basic types. The first one's what's known as a full travel actuator. And they're going to want to go fully in one direction or the other. Now, they're going to only move as long as there's pressure. You can always turn the hydraulic pressure on and off. They can move a little bit. You shut the pressure off and they'll stop moving. But if you maintain constant pressure on them, they're going to just go full travel to the left, full travel to the right, full travel to extended, full travel to retracted. And these are often used in these different areas. You can see here landing gear, right? It's rare that we stop the landing gear halfway up or halfway down mid-travel, right? We only need the landing gear to be down or up. Really isn't useful to us in mid-travel. Sometimes they get stuck mid-travel, and then it makes for an interesting landing. Doors, kind of a similar thing. Most doors are either fully open or fully closed. And when I'm talking doors here, this could be cabin doors, cargo doors, or landing gear doors. The air stairs. Now, you've all seen, we've opened the cargo door, that big cargo door on the 727. It will stop mid-travel if we release the switch, right? We stop it mid-travel to let all the rain, all the water drip out of it so it doesn't come pouring into the airplane. But if you just maintain pressure on there, that actuator is going to want to go fully extended until it hits a stop. Some secondary flight controls as well. Any idea what that might be? What a flight control would be that's always fully one direction or another, or fully extended or retracted? Certain types of spoilers, okay? Ground spoilers. Spoilers, when the plane touches down, they pop up on top of the wing. and they spoil the lift across the top surface of the wing. That way your plane doesn't want to bounce back up into the air. Okay, so those are often, if you have a dedicated ground spoiler, it often uses a full travel actuator. The other one that we have are servo feedback or proportional actuators. Now these are, technically the actuator itself is still kind of a full travel actuator, but they have an integral valve of some kind, an integral servo valve that allows you to kind of select how far you want it to move, and then the actuator only moves that far. And so this is important for things like primary flight controls, right? If you didn't have a servo actuator and you moved the yoke just a little bit and held it there, say to roll, the ailerons would continue to go till full travel, right? And we don't want them to go full travel when we just do a little bit of roll or a little bit of pitch. We don't want and so we have to have these servo setups where if I do a little bit of roll, it only moves the aileron a little bit. If I do a lot of roll, it moves the aileron a lot. Same thing with the elevator, same thing with the rudder. And so they have a servo valve and mechanical feedback. Or some newer ones even have electrical feedback. But primary flight control, secondary flight controls use these. So I've got a video that kind of shows how these operate. So you have a linear actuator, but on the end of it, instead of being connected to like a spot where you can bolt something onto it, it has this toothed, what's called rack right here. And as that actuator moves, in this case, kind of front to back, left to right, it's going to, there's an output shaft that's got essentially a gear, a pinion gear on. And it's going to rotate that. So the output is going to be a rotary output on this shaft. But is that rotary output going to have an unlimited number of rotations, revolutions? It's going to have a limited number of revolutions, maybe one, or if you got if the rack portion is longer, it might be able to rotate a few times. But there's still going to be a limit to how many times it can rotate in a given cycle before it has to go back. So it's kind of an oscillating motion type setup. Hydraulic motors, on the other hand, work like hydraulic pumps, but in reverse. So we looked at hydraulic pumps in detail, and we looked at these, we looked primarily at the axial piston type pumps in here, but in basic systems, you would have looked at the gear and vane and gerotor types. And if we pump fluid pressure into where, into the pump portion, that's going to force it to rotate mechanically. And so you're going to get a mechanical rotation out of there. And that will have an unlimited number of revolutions until the pump shells out, which they all will eventually. But it'll sit there and cause the pump to spin. And that can be those piston type pumps, right? We can put fluid against those axial pistons. We can put fluid against, around those gears, cause the gear type pump to essentially spin as a motor. And so it works just like a hydraulic motor in reverse. And we saw one of these earlier when we talked about a power transfer unit. Remember, the power transfer unit allows us to power one hydraulic system using another without transferring fluid between them. And it essentially is two of these. It can be a motor and a pump back to back, or it can be a motor pump combo on both sides where the power can be transferred either direction. And so if you put pressure into one, it causes it to spin. That spins the motor or the pump on the other side and creates pressure in the other system. As the fluid moves through the system, we want to be able to remove contamination from it. And so we're going to have several different filters. Now, most of these filters, are going to be our cleanable type elements, okay, in these high pressure systems. The vast majority that I've ever seen out there are cleanable. In an airline environment that I worked in, we didn't clean them ourselves. We had a back shop that they would clean them at. So we would replace them, but they were considered what was called a rotable component. And that is they get the filters that you pull out, they get sent to our back shop. If they have to do any kind of analysis, if there's metal or anything, they can do that. They clean them, and then they recertify and they put them back on our shelf to be installed in another airplane. And the ones that I'm putting into the airplane more than likely came out of another airplane and another airplane before that and another airplane before that. And occasionally we'd cycle a new filter in the system, but it was very rare. They were pretty much erodible. But they're a screen type element. There are a few hydraulic systems out there that may use a replaceable element, but honestly, the pressures in the 3000 psi range, and especially dealing with phosphate ester fluids, the replaceable filter element materials, like the cellulose paper type material, really doesn't work very well in this environment. Pressures are too high. The fluids don't play nice with a lot of materials. And so these cleanable elements, they're pretty much all wire mesh, wire screens. But they live inside of a bowl. So you can see these cutaways here. Pressure comes in, it travels on the outside of the bowl, goes through the wire mesh into the middle, and then comes up and out the outlet. However, over time, if this mesh starts to get clogged, or if there's something catastrophic that clogs it, there is a bypass valve up here, a little poppet valve, that if the pressure on the inlet is significantly higher than the pressure at the outlet, it will be able to force this valve open, and instead of going through the filter, the fluid just bypasses. You lose filtering ability, but the system's still able to run. Okay? And these had what they call a differential pressure button. So if the pressure got too high and it pushes this poppet open, not only does it allow fluid to bypass, but that pressure also comes up here and pushes on this little item, and it causes a little button to pop out of the top or the side of the filter head. Typically it's red, some of them are purple. But that's something that'll tell you. Now, some of them are set up where it's an impending bypass. It will pop before the pressure's high enough to actually open the poppet. Okay, that tells you, hey, your filter's getting dirty. It hasn't quite, maybe it potentially has not gotten to the point where it's clogged yet. Some of the filters already even had two indicator pins. One was an impending bypass. If the pressure across there got too high, it would pop, but fluid would still be going through the filter element at that point. If the fluid no longer went through the filter element, if it kicked open that bypass valve, then it would open the second button. So you see the first one popped. Okay, we need to clean the filters. We need to put clean filters in there. Hopefully that's all it was. You see the second one popped. You say, uh-oh, we had dirty fluid running through the system. Now you got to do a little bit more maintenance action on it. And when you see them in the airplane, they look something like this. And this is on the 727, and you can't see it, but there's these little hexes at the top here on the left and the right. If you look on the top of those, there is a bypass pin up there. So if this filter here, one labeled H, if the pressure across it was too high, this pin would pop. If the pressure across this unlabeled one were too high, the pin on that side would pop. But these are located in typically in three locations. So we have, and they're given the name, their name comes from where they are in the system. So the pressure filters are downstream of the pumps. Remember, the pump has three lines going to it. It's got a supply or a suction side. It has a pressure output, and it has a K-strain output. So the line coming out of the pump, the pressure line coming out of the pump, that's going to send your pressurized fluid out to the aircraft. Before it sends that fluid out to the aircraft, it's going to pass through a pressure filter. And that's there in case the pump goes bad. You don't want to send chunkies of pump out to the rest of the system and jam up all your actuators, especially when you have multiple pumps, right? Most of these have 2 or even 3 pumps. If one pump goes bad, it's really not that big of a deal. You can run on the second one until maintenance can be complied with once the airplane gets on the ground. But if the chunks of that pump were to get out there and jam everything up, then you're going to have a really, really bad day. So that's the pressure side. It's on the pressure filter. It's on the pump outlet before the fluid goes out to the system. The case drain, again, is to protect the system from pump chunkies. Remember that K-strain fluid is coming off the pump. It's providing lubrication for the pump. It's providing cooling. It's picking up the heat that's generated by the pump. That fluid's typically going to go back to the reservoir, either directly or through the return side. It's often going to go to a heat exchanger. But before it goes to either of those things, we want to, again, make sure that if the pump goes bad, we don't send pump chunkies into the heat exchanger. We don't send pump chunkies back into the reservoir where they could get sucked into the other pump. So we're going to filter that fluid. So that's the K-strain pump. Or K-strain filter, excuse me. Pump K-strain filter. There we go. So typically between the pump K-strain and the return side typically before the heat exchanger. And then the return is, the fluid then, the pressure fluid goes out to the system. It's used to move the flight controls, used to move the landing gear, and then it all comes back together in a return manifold, and before it goes to the reservoir, it goes through a return filter. And that way, if one of your actuators goes bad, if a hydraulic motor goes bad, if seals go bad and you get dirt or other crud in, or even if not, these actuators do get a certain amount of crud and dirt brought into them. The spot where the shafts go through, the rubber seals there, they're lubricated by a thin layer of hydraulic fluid that kind of leaks through. And as say a shaft retracts, the shaft extends, it gets dust and dirt on that surface, that chrome surface. As it retracts, it'll pull some of that dust and dirt back in through the seals, and then it gets in the fluid. And so these return filters are going to remove that kind of dust and dirt, and they're also going to protect from actuator chunkies from getting back to the reservoir and potentially being sent to the pumps and causing failures of the pumps. If you look at a diagram of a system, here's our different filters. So we'll start with the excuse me. We'll start at the reservoir down here. Okay. And we send fluid out from the reservoir, and it goes to the AC motor pump, 1B, and it goes up to the engine-driven pump, 1A, right? Okay, there's no filters there. But then we come off the pumps, we come off the pressure side of the pump. If you look at the engine-driven pump 1A here, the red lines coming out of it is pressure. You can see it goes through a filter right here, a pressure filter. And if you see ACMP 1B comes out, and there's some check valves here so fluid can't go backwards to the pumps, that goes through that same pressure filter before going out to the rest of our airplane. Okay, so there's that pressure filter. On both those pumps, you can see there's an orange line coming out of them. That's the K-strain. 1A pump goes to a K-strain filter before going to the heat exchanger and then back into the return side of the system. Same thing with the 1B pump, K-strain filter, heat exchanger, back to the return side. And then on the return side, everything in blue, when it comes back through the blue manifold here. It's kind of cut off at the bottom. I don't know why this is on here. You can see a line, there's a blue line at the bottom there, but for some reason this wants to stay, so. Let's see if that helps. Let's see if I can get it to go away. What's going on here? So now that our return side's showing, you can see the return is the blue coming from all these different actuators. It comes along the bottom, and everything going back the return side goes through the return filter here before making its way back to the reservoir. Okay. So those 3 filter locations. And I've got these labeled when you look at the slide. So there's our pressure filters, our K-strain filters, and our return filter in the system.